All right. So, yeah, as Vilma put it from NTNU, when I said this year's conference really focuses on getting the increased use of simulation technology, it just immediately shot back, yeah, but haven't we been saying that for 30 years? And I immediately shot back, yes, I know, even though I'm 42 and I was 12 at that time, so that was a lie. But still, apparently we're not done yet. So the overarching topic for this year's panel discussion is, well, I guess you could phrase it, if you were to phrase it as a question, it could be something like this. Simulation technology has never been more capable. I think the talks we have seen today and a lot of other things you've seen so far would definitely hint at that. Things are moving in the right direction. But how do we increase its use? Because maybe it's just me, but it doesn't look like we're quite there yet. Like the idea of the virtual twin, for example, it's certainly something that I feel the world needs. We need to get there, but it also seems like it's a very long way. Thank you. Back på knyttet. No, okay. Try turning it off and on again. Yeah. We also had a workshop last year on day 2. We, by the way, also going to have one this year. But last year's workshop, which a lot of people attended, thank you again very much for that. The focus was on identifying pain points with open simulation platform and co-simulation in general and adoption of simulation technology in the maritime industry. And I tried to summarize 4 main topics, also because they tie in nicely with our panelists' background and viewpoints. So one big one was the lack of competence and that there was a high barrier of entry. So one question you could ask about that is, how can we make simulation a living part of design operation? Another one was a lack of collaboration and IP concerns. How can we actually support collaboration? So maybe not just have co-simulation something that we use almost like comes in from the side, but it even could facilitate collaboration while, of course, protecting IP and maintaining trust. Then a thorny problem, I would personally say, is how do we actually demonstrate the value of simulation, let alone co-simulation? That's difficult to answer, but we probably have to figure out how we can do that if we want to have a buy-in from people. And then integration and lack of system responsibility, also very big issues. And the question maybe is, do we need more standards, better tools, or a shift in culture, or all of the above? I think I'm going to hop over this for the purpose of saving time. Except the clicker doesn't allow me to do that. Okay. This year, I'm going to do a little bit different. We would really love to involve you much more. So there is, if you check that QR code, if you go to URL, then you can submit questions or comments. And I will show you in a bit how that works. Also, the QR code will be on every slide that I'm going to use from here on out, more or less. So no rush. When you log on, or when you open the URL, it looks pretty much like this. You can submit your questions here. If you want to, you can choose to be anonymous when you do so. You can also upvote questions. So of course, feel free to come with your own comments and questions. But if there's already a question that somebody submitted that you think is awesome, then definitely give it a thumbs up. How do I do some? Okay. And you can also, in these feely times, let us know how you're feeling at any point in time. If you click on the thumbs up there, then you can tell us if you agree, if you applaud, or if you're confused or in love. The being in love part was requested from me, had to be put in last minute. No, I'm just kidding. All right. So with that out of the way, it is my pleasure to introduce Huub from Damen, whom you've already met. Wouter from the Salt Systems, whom you also just have met. Klaas, who you kind of have met because he already asked a million questions, which of course is good, not complaining. And Paul from Sintef Ocean, whom you also have met. So I would kindly ask you to briefly tell us who you are, what is your role, and if you can, maybe say a few words as an opening statement related to the question, where do you see the greatest untapped potential for simulation in the maritime industry today? Anybody wants to start?
I think I can start. Yeah, so my name is Huub van der Broek. I work as a research engineer at Damen Shipyards. And to answer the question, where is simulation still lacking, or where could it be used? I would say almost everywhere. So from the integration part of the vessel, so really early on in the design. But also what is very interesting is to use, once you have the model and the ship is already being used by the customer, that you can use the model later on to optimize the vessel. So what we are looking into now as well is to, for energy management systems, for example, is to use data from how a vessel is being used by a customer, and then optimize EMS set points to make his operation more sustainable, less fuel intensive, or to make the batteries last longer, for example. So you can use simulation in the whole life cycle of the vessel.
So it's all an untapped potential, basically.
Yeah, exactly. Yeah. You can use it anywhere.
No, that's fair, I think.
Yeah.
Yeah, thank you. My name is Klaas Rostock. I'm from DNV, 26 years in the company. I have worked for about 16 years on board vessels doing experimental investigations. So those were the years, I think, where I picked up a lot of systems understanding, not necessarily by academic research, but by very practical experience. But I could take that then on land, so to say, into systems engineering and system simulation, which I'm onto since 10 years. I'm currently also working in group research on the role, especially the role of simulation in assurance. Biggest untapped potential, I'd like to mention two, but the first one is not really, I mean, while being a potential, it is more a necessity as I see it, and that is that we need simulation also in assurance. There's no way around it because the systems become more and more complex, but that alone is not the main point. It could still be handled by manual processes, but second, they also change. And we are not able to re-establish trust upon invalidation due to changes with any type of manual process. So the evidence creation needs to become automated. That is simply a necessity, and hence going model-based for me is a must. There's no way around. The untapped potential maybe is for me lies in the ecosystem and in the value chain. What I wonder is why is there not stronger uptake in actually providing models, or say having ownership and having responsibility behind models, for instance, also from supplier side. There are huge advantages also contributing a model. And we heard from Airbus, they also say struggle a bit in how do they do the contracts with those suppliers. But for suppliers, it's fantastic. They can gain insight. They can gain insight into how models are being used and so on and so on. It's not just about marketing. It goes way beyond it. And they also tapping into a digital business means, so new business models that even extend beyond delivery of their assets. That's from my end.
Mm-hmm. Paul, maybe you?
Should I continue? Okay, yeah.
Sure. Oh, you have your own. Okay. You guys have your own mics.
Yes, so my name is Paul Level. I work in Sintef Ocean as a software developer on SIMA, which is one of our simulation workbenches. It's used a lot in the offshore industry, so I showed you a floating oil platform before lunch. It's also used for planning of lifting operations. And one big potential I see for use of simulation is pushing it closer to the actual operation. Engineers will typically use our software during planning to see what is the acceptable weather to do a given operation in. But it's a big potential if you can include weather forecasts in that, pushing it like even closer to the actual decision point, and maybe even you can include sensor data as the input to your simulation. It's a lot of interesting topics.
Just kind of pushing left, but also pushing right at the same time, like pushing on both sides. Huh?
Yeah.
Wouter?
Yeah, thank you. So, Wouter van der Velde. I, from origin, an aerospace engineer, been working for about 10 years at Dassault System. And my role at Dassault is to define basically the portfolio of our, let's say, multi-physics simulations for the maritime industry. Because we, as you just saw in the presentation, and I just barely touched something, but we have we're an enormous company, 25,000 colleagues. We have a lot of different software, but they are general purpose, right? So that means that you can design a car with that, and you can design an aircraft with that. And what I'm trying to do, because those are actually the two driving industries because they are the most, and that's sorry to say, but also one of the feedbacks later, it's they are showing a higher level of innovation currently than the maritime industry. It's very conservative, and I think that's something, first of all, why we can learn more from simulation. But due to that, right, the tools itself being general purpose, I try to find workflows, processes, go-to-market material, which then fits customer needs for the maritime industry. So that's a little bit of my role. I think I was kind of hopefully clear in my presentation why we need more simulation and where we would need it. I'm a very big favor of I think everyone has good points and all agree, but I'm a very big favor of the left shifting algorithm, which you also mentioned in the morning. Kind of call it democratization. So where before subject matter experts who are very isolated, right, and know everything about a specific hydrodynamic calculation, it would be a waste if you do not use that knowledge earlier in the design. Because that, I mean, for obvious reasons, that avoids late-stage failures, but it also allows you to do optimization. And the more you can do the more you include simulation, I think the more you can do optimization.
Yeah, very good. Yeah, also, before we get, and we will take those, one important thing I got to mention for the audience, if you don't only have to submit questions, you can still use microphone and your own voice. So if you want to do that, I guess raise your hand. We'll do our best to see it, and then I'll try to include you as early as I can. Please, Millie. Maybe I should give you the microphone, yes.
Thank you. It's about the right shifting concept you mentioned. So the question is, do you agree that the simulation technology is tool, not a goal itself? How can we integrate the product, money, profit concepts in teaching and expanding simulation process? Should I repeat again?
Yeah.
Yes. Do you agree that the simulation technology is tool, not a goal itself? How can we integrate the product, money, profit concepts in teaching and expanding simulation process?
So it's about the integration of I guess, the whole business logic around?
Yes, like, I think it's related to right shifting also concept that we mentioned directly.
Yeah. Any takers on that question?
For me, it's still a little bit of puzzling, the question. But
But if I understood correctly, it's I mean, maybe that's the entire question, but one point is how do you, I mean, isn't, maybe the simulations we've seen that's like to what extent does it include the actual value you get out of what you're doing and like tying it up into what really matters at the end of the day, which is making money?
If I think it's the avoidance of late-stage failures, one crucial part, right, which saves you money, right? You're all. Secondly, I think reduce physical prototyping. So manufacturing costs to build demos, to build models. I don't want to burn down all the experimentalists here because I'm a simulation engineer, but I see big value of adding simulations. Left, right doesn't matter to reduce the physical prototyping and the model testing, especially in those harsh conditions, right, where you want to maybe tailor or work or design for a single condition, or you're going to wait for months until that condition appears. Maybe you would say so.
Yeah, again, if I read the question correctly, maybe it's also, I mean, you could include business metrics and cost or profit into your optimization algorithm based on simulation, for example. Although that's certainly not easy to do.
Yeah, and I think it's the first part. I think it's important, like simulation is and should always be one of the tools. Like if someone's gonna do a lifting operation offshore, put something on the seabed, at the moment, if your simulation says yes, but the captain says no, and people still listen to the captain, and you should be pretty sure. You should be pretty confident in your simulations before you say go on something that the captain says no to. But so being conservative to some extent is, I think it's important. But how do you get better? You have to push the envelope as well. I don't know. That's for the stakeholders and not the model developers as us.
Yeah. If there's another, yeah.
The second one is, I'm just reading it. Devil's advocate. If simulations offer such a significant evolutionary advantage, why hasn't natural selection already run its course?
That was an interesting question.
You want to...
Klaus is ready.
No. In contrast, I didn't really pick. I'm sorry. Second part. It might be just me, but I think it's behind it.
Yeah, devil's advocate question.
Yeah, but
if it's so awesome, why are we not already doing it all? And
before handing over to you, at least my immediate thought is that what we are completely missing is integration, because it's siloed. Simulation is being considered an engineering work, an engineering activity being rendered by someone or by a team or something. It is not being considered an artifact that's being maintained, that's being used to represent something. There's someone standing behind. It is more of an activity. Someone runs a calculation, comes back and says, yeah, it's okay or not. So and I think and that combined with the siloed approaches, because most of the simulations are so locked down at different companies. Maybe that's one of the reasons. That my immediate thought. Now I give to you.
Yeah. So I don't have a maritime background, but I'm originally from the automotive industry. But what I've seen now is that the maritime is also maybe a bit more conservative in terms of trying new things. So we use, of course, a lot of simulation on the as research projects, but also in the actual ship design, still a lot of things are done with calculating in Excel, for example. And that also works up to a certain extent, of course. With modeling, you can achieve a lot more, but it's difficult to prove to so many stakeholders in the entire company that, where should we go with simulation? Should we use it already in a new project? Or should we first try it, redo an existing project, compare the results, for example? But that's, of course, very expensive to do. But if you would try it on a new project and it fails, that's also, you cannot do it. Your first vessel is not only your prototype, but also the end product of the customer. So maybe that's also why it's a bit more difficult than in automotive, where you first test everything, you build 500 cars that will be scrapped, and then you start the actual production. So it's a completely, quite a different industry as well than compared to automotive. So maybe that's why it's a bit more difficult to integrate more and more simulation. And it's difficult to prove what it will bring in the end. Also in terms of cost saving, what was the previous question?
Very good. Should we continue with the prepare question and maybe back to, because I noticed a failure in design here, which is I have to get up and press the key. I also have to get up to actually see what I've written. Co-simulation often exposes the differences between organizations in tools, interfaces, and even vocabulary. And that vocabulary part is not the trivial one. I've experienced it many times before. We've all seen it today. People say simulation, they might mean different things. How do we make collaboration technically feasible and culturally acceptable? Sort of a big question. Well, we have 4 smart panelists. I'm sure they have some opinions on this. Because this is also a theme that's being mentioned or that we touched upon many times. It's just, I mean, there's enough to figure out on a technical level to make us collaborate, and we are far from having all the tools, although we certainly seem to be going in the right direction. But it seems to be much more than that. So is it more a cultural shift or both? But it's interesting again to see how the differences are in the organizations, and you who have seen this firsthand with your co-simulation.
Yeah, exactly. So we have seen the difference in understanding of definitions. So that's, of course, also difficult to solve. You will solve it along the way. So maybe it's just more a cultural shift that we should do. So, and also the picture I showed of the iceberg, you first see the first issues, but most of the issues are below the waterline when you actually are doing the project. So you will of course encounter all of these problems, but most of the time you will fix it, of course. But
so you see them when you're underwater, when you're already drowning.
Yeah, when you're drowning in the problems, you will find the solutions as well. But you first have to see the problem to know how to solve it, of course. So I would say just start doing it, and then you will find out eventually.
Yeah, that's kind of like also like when I talked to you and you told me a little bit about the co-simulation project you have at Damen. Is maybe you just have to get going. Maybe you just have to cojones to just say, okay, this is our first co-simulation project like you have had. It's not going to be perfect. We're going to be inefficient. We're going to be idiots. But next time and the times after, it's going to get better and better.
Yeah, exactly. So I think that was also the goal of why we did this project now with the co-simulation, is to learn a lot from it. And now, we made a lot of mistakes, of course, found a lot of problems, but also a lot of good solutions. And I really like where it is going as well with the solution that we have. So I think, you should just do it, and then you find out eventually the benefits of it as well.
Yeah. Paul, do you have?
I think if I can add something, I think a lot of the challenges isn't really technical. We have a lot of technical solutions. It's a lot of human problems. You need to get the right experts in the same room, or on Teams, in a virtual room for that matter. But experts that usually don't talk together need to talk together. And at the same time, the subject matter experts might not know how you connect tools together in the best way. That's maybe more a topic for, like me, which is a model developer. So you have a lot of different people with different competence that need to talk together in order to get something like a co-simulation, an advanced co-simulation going. But like I saw in the project I presented earlier today, when you get the right people who has the right knowledge, then it works, and you get interesting results. Even if the co-simulation isn't that advanced, connect fairly standard simulation software together, and make it exchange data, you can learn a lot of it. So the potential is there, but you have to get the right people.
But this maybe also means, if you understand this correctly, that you maybe don't overthink it in terms of what you want to do and the technical aspects, but keep it simple and
like
get going.
Like I say, this is the first co-simulation project. It might not be perfect, but it's probably better than no co-simulation project.
Yeah, cool. We have, sorry, of course. Yeah, it might be.
No? Okay. Culturally acceptable. And I thought, the technical things, I think we can sort out if we want to. So the cultural acceptance is also about, do we want that? Is there a push in the companies towards co-simulation? And this is something I'm a bit missing, so to say, right? Because if there is a willingness and if there is a push and there's an interest, then the technical stuff can be sorted out. On the technical side, and apart from standards and I think ontologies also, and I know the aircraft industry, aviation, they have huge ontologies, and maybe we need to come up with something as such also in maritime. But one thing strikes me, and that is there is a role to play for the system integrators. And like you, like the yards, you have to stand up and take responsibility to integrate the system, because the system does not properly work by just throwing in components, and there is no confidence in a component, or there is no trust in a component if you not specify what it is used for, in which context it is used for. And that's the task for the system integrator. He needs to say, this component is going to be used in this context, and this is why I require exactly this behavior from that component. And I am the one making sure that what you have as an output fits to the next one who uses it as an input, and that maybe even in between there is a little bit of buffer that gives me some risk buffer and uncertainty reduction as a system integrator. And this is a dedicated role, and it needs to be taken. And I have seen in my career many projects at large shipyards with large, very complex vessels, where when anything didn't work, then it was just kind of pinpointing, and the yard oftentimes was leaning back and saying, "Oh, we'll clarify that among you. I mean, right? We paid you all well," and that's not enough, I think, when it comes to collaborating in the digital domain.
Just make sure when you deliver a model that you flip one of the coordinate axis around randomly.
But there's a lot of the presentations earlier today that highlighted that coordinate systems are challenging, and getting it right across different models. Maybe like that. Yeah, coordinate systems are challenging, and we need to be aware of it. And yeah, I like your point about the system integrator is a crucial role here. It's knowledge you need.
And I on top of that, I think the class said is very good. I think and it ties back to an earlier question about what's the benefit, right, for your company, right? But it's the system integrator very crucial, but even I think it should also still start from your higher management, right? The question was what's the benefit of simulation for my company? That needs to be clear, right? You want to reduce capex and opex costs, and thanks to the help of more simulation, this is achievable. So in the end, it should also come a little bit from higher up, right? Where you've been asked to work more efficient and start doing optimizations so that you can actually be, what was the question again about human nature compared to system simulations? I think what the goal would be is actually that simulation is accelerating way faster than evolution, right? That would be the goal. And I think that should be the answer of doing more simulation, more complex simulation, but also making complex simulation easier. And then we talk again about for example, code simulation or building templates or processes and whatsoever, but it would help you to eventually be more efficient for your company and do the evolution faster of your products.
Yeah, that's a good answer. Do we have, how are we looking for audience feedback? Wait a second, Millie. Yeah.
How important is an open simulator platform? Or is everyone doing their own things in the simulation side? So it's about collaboration and willingness to collaborate.
So it's I mean, it could be interpreted two ways. Maybe if it's like OSP critical, could be interpreted as that, or could be interpreted as do we even need like an open platform because everybody has to do their own thing? Maybe it's the latter. No. Yeah. No. Right. So is it like, do we even need an open simulation platform solution of sorts, or do we all need to do our own proprietary thing anyway?
First thing is, if you want to collaborate, then you need standards. So you need to agree on standards. Whether the environment where you actually execute simulations is something that it needs to be shared. Whether it needs to be open, I don't know. That's a bit of maybe also up to you as an industry. We're having assumptions and exploring assumptions. One of them being that we thought a protection of intellectual property is important to owners of models. So having a shared co-simulation always means that there's you need to provide somehow access to your model so that it can be co-simulated. So that might be an issue. So maybe then there need to be technology processes in place to safeguard IPR. But whether and to what degree that is really decisive, I think, to be honest, we don't know yet. And we hope for more trials and more experiences and more feedback from the industry. So how big is the pain, and how much value is in protecting IP, in providing a secure environment? How do we realize a multi-stakeholder collaboration? Because there will not be the one platform in the end where anything is being consolidated in. That will just not happen. So there needs to be communication that can be, say, data artifacts. It can be models, but certainly we will want to agree on standards allowance. Open, and maybe to clarify that, I think I did mention that before on one of the other OSP conferences. I still feel that the term open simulation platform is a bit unfortunate, because it is not a platform, right? There is no platform. It provides the technologies that allow for co-simulation, and that's fantastic. We have a great co-simulation engine, and all of that is open source. But where do you run this is basically up to you, and how much protection would you wish in that environment to separate individual models, for instance. So in the STC implementation, we have sandboxed models so that no model can even, say, go out and do some weird stuff. But is that important? Honestly, we don't know that. Tell us, and tell also Dassault and Siemens and whoever's out there, I think.
Yeah, maybe I can jump in there a bit as well. So yeah, we use the STC platform for our co-simulation project. And I think that does help, especially since it's quite new, that a supplier can deliver their FMU on the STC platform where it's completely locked out. So you cannot download it from there. You can set who can use it, who can run the model, what you can do with it. But you can never, who you give access to the model, you can never, they cannot download your model, for example. So I think especially in the beginning, it will help to build the trust between parties, let's say, and also for debugging, for example, it makes it easier that you have one platform where you host the entire simulation, that if there is an issue, you can, yeah, you're looking at the same thing. And if you would run it somewhere else in your own modeling software, then it's also more difficult to for a supplier of a model to see if it's their model that's causing the issue or something else. So I think it's quite helpful to have some type of platform where we can do co-simulations.
I think having free, at least theoretically, they don't have to be open or open source, but free software like libcosym available would significantly lower the barrier, because you can get started very easily. Like you can start locally with your own simulation tool, and you can make up something and see that works, and you can advance to collaborate with one more vendor, maybe move to DNV solutions and so on. But it gives you like a path up towards a bigger picture.
Yeah, I can have one positive and one negative thing, actually, if I'm thinking about it. I think the biggest positive thing, right, is that if something is open and you work on it together, it just drives innovation, right, and it accelerates. So only more wonderful products will come out of it. I think that's the key of getting or working on a co-simulation engine. The counterpart, which I want to mention, is maybe more from a company perspective. When people are using open source material, they have to rely on their own R&D or engineers. Maybe they have to hire additional engineers to keep up, right, or to maintain. And this is something which, and then, yes, promoting maybe myself or does so in general, but what on the counterpart commercial software does offer, right, is that you are pretty certain that whatever you buy, well, most of the time, I would say always, but most of the time would work, right? So I think that's the counterpart of the fact that things are open. And I've experienced that myself before in university when doing, I don't know, CFD calculations with OpenFOAM, for example. Wonderful product. But yeah, it can also go, a lot of things can go wrong, you know? So it's nice that it's open, but it probably would require you to also have more resources, human resources to work on it. And that's something sometimes a company doesn't want to, and sometimes they want to, you know? So,
yeah, it probably needs both as part of the ecosystem.
And I think that's what makes the connectivity then at some point. Yeah.
All right.
Yeah, I think the mistake people often do is that they think that free and open source means cheaper.
Yeah, exactly. That's a good statement. Yeah.
Mm-hmm. But that's not necessarily the case.
We have more questions you would like to bring up?
One question related to OSP. What is the top 3 concrete points that needs to be standardized better in order for OSP to be adapted? Top 3 concrete points.
That's a good question.
Risking that, not sure whether I should say, but my personal opinion, being we should think about turning what really differentiates OSP or what OSP adds to FMI, because FMI is an established standard. So, right, OSP does not want to compete. In contrast, OSP was the whole intention behind OSP was to adapt FMI to the maritime industry. And the adaptation, is mostly distilled in the OSPIS and the interface standard. And I would vote to turn that into an FMI layered standard to increase, say, the acceptance and also to closer link with the FMI community and communicate clearly that no, we as OSP, we might be an industry community, right? But we're not something apart from FMI. In contrast, we're building upon FMI, we're supporting FMI, and what is industry specific, we contribute and ingest into the FMI community in terms of a layered standard. That's my 2 cents.
Mm-hmm. Am I allowed to comment on things too? I feel I should be allowed to comment on things. I don't know if I can come up with three, but I would say one big one is the model interfaces. That's not only OSP, of course, it's not only maritime, but it's also specifically maritime. And of course, we've started on that, but that's still such a pain point. Coordinate systems would be one sub-problem, not the only one in that realm. And maybe also think like this moving left thing and right, I guess, thinking about how we can standardize workflows maybe. I'm not sure if standards is the right way to think about it, or more like guidelines, best practices, again, which we have started with, but it seems like there's a need for more. And then the last quick comment is that I work a lot with data and machine learning based on operational data from ships, and we're trying now to come up with a framework for how to structure the data from ships and to build a pre-processing framework. And it hits me that maybe those two things should also not be developed completely in isolation of each other.
No, please go ahead.
One thing that keeps me awake at night at times is I feel we need to find the holy grail to some of the integration problems for hybrid vessels, some complex systems. And there's a famous that goes like, I think, if you want to understand the world, think about energy, frequency, and dynamics. Or I think he said and vibration, but I think it's too close in its meaning. And to have a generalized, really robust generalized form of how do we separate the concerns and responsibilities in a typical hybrid electrical vessel design. Is there something that we can standardize and agree upon as these, not only for the formal interfaces, but also for the responsibilities? What are the different components meant to do and meant to take care about? Is there responsibility maybe that shifts in under certain operating conditions, that one component takes over responsibility from another, and so on? What does that mean? Thinking about multiple diesel generators on the grid, because simulating everything in the 60 hertz time domain is just not feasible. We need to simplify it in an abstract way. I have a hunch that is still possible. I think power bonds are not the end of the story there, but agreeing on something that, okay, that's kind of our reference standard, this is the way we do it, that would be fantastic.
We're closing in on an end for this, unfortunately. I wonder if, how are we looking like in terms of audience questions or comments? How about the upvoting? Is there a clear winner amongst these five that we could pick? Or? No clear winners, no? Yeah. Otherwise, I would have prepared like a final kind of a little bit of a visionary question to round off, but it's not clear to me. We don't have so much time, and it's not clear to me what's better. There's no way for me of asking if that's a good question that you have there in your lab without actually asking if it's a good question. Yes, that's also a good point. Has anybody maybe? Yeah, there you go.
Are they on the screen, the questions? Or? Oh, no. Oh.
Yeah, hello. Thank you. Very, very interesting discussion. And in your presentation, you mentioned sustainability in different ways. And I'm wondering, how do you integrate, for example, databases that contain sustainable information into the simulation platforms? Are there any combination today, because it's from different vocabulary or different language or different disciplines? And how are you? What is the status on integrating sustainability information in the simulation platforms?
Can I ask, because I'm not sure I'm familiar enough, the simulation sustainability information like as a result of simulation, that you know, like how sustainable a solution is?
For example, if you want to look at the sustainability aspects, How do you integrate, for example, LCA data into this and give it with information by these type of indicators?
Yeah, very good question. Any opinions, thoughts? Yeah, for me it was more like on the result side. Like, for example, I want to know how energy efficient my ship would be. So that would be something that comes out on the back end, so to speak.
Yeah, well, I agree. I think we need to also acknowledge that LCA assessments go way beyond a one-dimensional optimization problem. And there's a whole science behind LCA, and I think at least say in my vicinity, I haven't been in touch so intensively. So there's one EU application we now have out that where LCA, it's a one topic where LCA really shall be tied into the process. Also for design, for modular design, that it is really a distinct aspect that is made a firm element for the assessment of designs. But I don't know whether it's going to be funded. Just saying, yeah, we want to do that. I can only say this is a great question. What I also, at least from my point of view, I'd say it's not very developed, how it's connected into simulations and into workflows so far, to be perfectly honest.
Yeah, I'm not entirely sure either if I understand the question completely, but I envision that you like to, as you said, you like to optimize or work towards more sustainable vessels. Maybe after they are produced, for example, and track the data. In that sense, it can be coupled to condition. As I mentioned next to me, net conditioning monitoring, I think that's a crucial aspect. And for example, if you have a digital twin or virtual twin, I don't care how you name it, but you can take the data from sensors from real-time vessels and link that into your system models and extract new or updated information on maybe changes you have to put into your engine or maybe even positioning, you know, can be anything. So I think to strike or to aim for more sustainable routing, for example, this is something which is already done, and also simulations are being used for it, right? So you take data from from your real-time trajectory or routing and use that in your system modeling in order to adjust anything you can think of, right? It can be engine settings or it can be maybe trajectory. A nice example is I think one of the presentations was showing some wind shipping propulsion, right? So those sails which we're putting back on ships. There's an entire market now studying the optimized routing. And you can study that ahead of time, but obviously you need to study that while you do your routing, right? So it's kind of optimizing along the way. And in that sense, you are using your simulation tools and your models.
Yeah, I was also wondering if the virtual twin idea was basically could be an answer to that.
Yeah, but I mean, it depends if you really design, right? You're from scratch, you don't have anything. You can think about minimizing mass that is sustainable, right? So I wasn't really clear if that was the question.
All right, unfortunately, we have to move on. There's a medium angry Norwegian in the corner there who's sending me these kind of signals. But this was a pleasure and an honor. Thank you so much for participating, also to the audience. It was awesome to see so many questions and comments. And yeah, I feel like I forgot something, but thank you.
Thank you.
Knut Tore, what's